Hello, everybody. I'm your host, Mike Vizard, and welcome to Cloud Native Goes Native. We're going to be talking about microservices with David McKay, who's the Senior Developer Advocate for Equinix Metal, and hopefully we'll be joined shortly by Charity Majors, who's the CTO of Honeycomb. And I'm going to start this conversation with a pet peeve, but before I get into that, we're going to do a little housekeeping. There's going to be 4 $25 gift certificates that you're eligible for, so make sure you stick around to the end for that. And also, we're encouraging folks to participate in the platform, so find the little chat button, and if you hear something you want to ask more about, I will find your question, and we'll share it with our experts of the day. Speaking of which, David, welcome. How you doing?
I'm doing very well, thank you. How are you?
I'm good. So let me get started with my little pet peeve. It's the phrase cloud native itself. Drives me crazy. Everybody claims that they're cloud native now. And if I've got, 2 VMs and I stuck a monolithic application up there, I'm going to call it cloud native. And I feel like the term should be more strictly enforced in terms of what it means. To me, it means microservices, Kubernetes enabled. I can scale up and down as required. I'm not having to necessarily make a major commitment to resources. Do you think that I'm being unreasonable in my expectations, or am I, just a little bit over the top here? What do you think?
It's a tough one, isn't it? Because the term, assuming we didn't have the cloud native foundation, could be easily understood to be anything that is built to run on the cloud. But we do have the cloud native foundation, and that term used to be very specifically defined. In fact, if I remember correctly, 2016, the description of cloud native on the CNCF website used to have 3 properties. Those 3 properties were dynamically orchestrated, runs in containers, and microservice based. Pretty much exactly what you just said there was the correct definition of cloud native. Unfortunately, the CNCF have updated their website now. The definition is a lot looser. It's not as dogmatic as it once was. And I think there's a little bit of scope now for people to say they're cloud native, even if they don't meet that more traditional or legacy description. But I think those 3 things are still very, very important to modern cloud native applications.
I'm with you. I feel like this is scope creep, right? This classic example. We're just kind of out of control here, man. Where is our DevOps engineers to keep everybody in line?
Yeah, running a single container on Amazon AWS or whatever may not mean cloud native, even though you're natively running in the cloud. And I think maybe providing a more pragmatic approach to understanding cloud native would be well regarded all around, I think. Yeah, I think I'm with you on that one.
All right, let's assume then we're going to be talking about microservices, containers, and things that scale up pretty dramatically. Where do you think we are in this evolution? I've seen all these survey numbers, and it seems to say that everybody's built some kind of microservice, and I'm going to assume that means they built maybe one or maybe a half of one, or they tried. So where are we on this longevity? Because I feel like there are ISVs out there that probably have entire apps built around microservices, and they're pretty far along. But the enterprise guys, maybe not so much. So are different folks at different places? What do you think?
Yeah, definitely. Everyone is at different places. I think that's guaranteed. I think we're still very early, and people that are already attempting to, not only write microservices, but orchestrate them and monitor them in production are still in the minority, I would say. I think we've still got a lot of technical challenges that come from adopting microservices that aren't really solved as commodity yet. And we're probably still a good few years away from that. So I haven't seen the numbers that you're talking about, but I think we're still very early with companies and people approaching microservices, adopting microservices, and operating microservices.
All right. Charity, is that you over there?
Yes, hello.
Hello. How are you? Welcome. So we're just talking about microservices and where the maturity curve is these days. And it seemed like a lot of ISVs are pretty far down the path, but in the enterprise, not so much. So do you think independent software vendor, an application provider, somebody of that nature, like an SAP or Salesforce or somebody like that, versus your average enterprise that's building their own custom apps? So What's your sense of where is the average enterprise as it relates to maturity curve of microservices and cloud native technologies in general?
I mean, enterprise technology isn't really my bag, but I mean, it seems like people are starting to try it out and make all of the common mistakes. So I'd say pretty early.
All right, all those common mistakes. So why don't you describe what you think some of those common mistakes are? Because there are lots of dependencies, and what do you think people should be looking out for in your experience, or better yet, what do you know now that you wish you knew 2 or 3 years ago?
Either they wait too long to do it, or they go headlong into it and they're like, microservice all the things. Let's have 5 microservices for every single developer. Or they fail to make the operational shift. I mean, a lot of what adopting microservices means is just pushing operational considerations into the realm of development, and a lot of developers aren't prepared for that. I feel like the first wave of DevOps was all about yelling at us people, learn to write software, learn to write code. We're like, okay. And like second wave is all about, okay, software engineers, like it's your turn. Time to learn to write operable software and to learn to operate, your own services and be on call for them. And, that's just a transition that's going to take a while.
David, is that a goal that we want? Sometimes I wonder if we're asking too much of developers to take operational control.
Basic shit. Like, sorry.
Go ahead, jump.
Feel strongly about this. If you're building software for a 24/7 available service, you own your software, and there's no 2 ways around that.
Yeah, I completely agree. I think I've always been very lucky in my career. I've always worked for really small companies that when I write the code, I'm also responsible for deploying it. In fact, I've never really known any other way. And I think I'm lucky in that regard. A lot of people don't have that experience. But now is definitely a good time to start picking that up.
The thing is that people look at this as being harder or something, and it's not. This is the easy way to write and build and own software. This is the only way to write and build and own software that's maintainable over the long run. If you have one person with the original intent in their head and the other person trying to figure that out and trying to operate it like independently of that, it just doesn't work. And this is not to say that ops people are going away or that their skills are not necessary by any means. It's just that we need to be more like consultants internally who help software engineers, because there's a lot of specialty knowledge there just involved in building these services and instrumenting them and observability and just figuring out how to the balance between getting alerted when your users are in pain but not getting drowned in alerts when it's not necessary. There's a lot of expertise there, but when it comes to actually running the code that you own, like your developers have to own it.
Let me play devil's advocate on that, because I have talked to a few enterprise guys about this, and their opinion is I only have like maybe 50 to 100 developers, and I want all of them writing business logic, and I don't want them writing infrastructure. I know you've heard this argument, so how do you counter that?
Well, that's fine. It's just that, your incidents will take the most efficient way to build software and spend most of your development cycles on feature work is actually to have software engineers owning their stuff. The blast radius, there's no such thing as a free lunch. You can't just let someone else run your software for you and not pay the price for it. You find your bugs more quickly, more easily. The sooner after you've written that software, the better, right? Ideally within a few minutes of writing it, right? If your development cycle is taut, if it is within 15 minutes, you're writing the code, it's out in production, you watch it, you watch users use it, you'll find like 80% of the bugs right then and there. Now, you can choose to just like not look at it and let your users find the bugs for you, days, weeks, months, years down the line. But it will be harder, it will take longer, it will take orders of magnitudes more developer and operational resources to find and fix those bugs.
David, you agree with that, or is there a middle ground somewhere?
I pretty much agree. I think, best practices indicate that we should be continuously delivering whenever possible and monitoring our software. We have to have short feedback loops everywhere. I don't think anyone is really going to disagree with anything there. But of course, going back to your enterprise example, is that this isn't something people can change overnight, especially with a lot of legacy. If we think about enterprise software, like they're probably writing Java that's running on an old JVM that's just not going to work in containers, but they still want to adopt microservices on the cloud and do really quick horizontal scaling. And they're just
you
not
must
going
do this call to ride this ride. If your developers are not owning your code, you cannot adopt microservices.
All right. How do I deal with the number of microservices and all the dependencies? I think some people get intimidated. I also think I know some people have started down a path and rolled some things back. And how do I kind of approach that in a way that is reasonable, of success, or is that part of the ride too?
It's really hard to answer this question generically because so much depends on your the problem you're trying to solve, the legacy of the code that you've already written. There's no playbook you could hand someone going, just do these things. It's very specific.
All right. Have you seen people get overly aggressive with microservices, and maybe they should think about some things are good as a monolith or some things are microservices?
Absolutely. If you can solve your problem with a monolith, please do so.
All right. David, that's the same way, or, monolith first and microservices second?
Yeah, I think it's difficult to turn around without, understanding the organization and the dynamics and how they work, right? But if I wanted to try and apply a really wide rule to this here, then starting with microservices is probably not the right idea for anyone. Monoliths are easy to work with at a certain size, until you make it a ball of mud. You're going to do really well having that code shipped together, deploying it quickly. Eventually, you'll probably get to a point where there's too many developers, where too many intermingled components, and change becomes difficult. And that is a symptom. That is a sign, okay, we need to address this. We need to find a way to fix this. And microservices may be an answer. But to start off with microservices and take on that operational burden of service discovery and distributed systems and state, probably not a good fit for any team.
How will I go about monitoring these microservices? One of their attributes seems to be that the containers inside them get ripped and replaced. Sometimes the entire microservice gets ripped and replaced. How do I kind of manage that in a way that I can cope with or keep pace with? Is that part of something that I have to dedicate somebody to? I mean, we hear a lot about the phrase observability. What does that mean in the context of microservices, Charity?
Same thing as anywhere. I mean, it means that you're instrumenting your code with an eye to how am I going to understand if what I'm writing is behaving the way I intended it to, if it's doing what I meant it to do, and if there's any unintended consequences. Monitoring is very much more friendly to black box things, I don't understand how this thing works, but I'm just going to set some arbitrary thresholds and kind of tune them over time until I get something that's more or less okay. Observability is much more about, observability becomes incredibly important when you're moving to microservices, because with a monolith, if all else failed, you could just attach a debugger and step through it, right? Just like, what the hell is going on? Just like, doop, 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 and you can see what was going on. Well, you can't do that anymore because you blew up your monolith and now it's hopping the network all over the place. And all of that context that used to be passed along with the process ID is now getting lost. And so a lot of what observability is gathering the context of, the request as it makes its way through the service and packaging it along with it so that when it hops from service to service, you don't lose it all.
How hard is it to instrument microservices then? Because in the land of the monoliths, at least, people were less inclined to instrument only their most mission critical applications because it was hard to get the agents out there and manage them, deploy them.
It all depends, right? Like every single question you've asked us, the answer is it depends. like at Honeycomb, something that we've done to make this easier is we wrote, client libraries that when the request enters a service, we initialize an empty event, we pre-populate it with everything that we know, all the parameters, all the environment variables, etc. And then we make it so that as the process is executing through the service, you can stuff in, user ID, any IDs that you think or timing information or whatever that you think is useful. And then when the request is ready to exit or error, it ships it off to Honeycomb in one arbitrarily wide structured data blob, which is the best way to do it. So you can write your own libraries, you can use Honeycomb, but of course it's difficult if you're just starting from scratch with none of that infrastructure. I don't know. The most important thing is that it be instrumented in a way such that you get one arbitrarily wide structured data blob per request, per service. That's what makes it easy to package up that context with the request as it bounces around.
What is your take on those open source agents that people are talking about versus whether it's a library, or does it matter, or should I use something from a vendor, or should I?
Of course, it matters a lot. OTel is really promising, but OTel is really just it's a wrapper, basically. It's meant to make instrumentation generic. So this is great for users, by the way, because if you've instrumented your code with OTel, it means that you can try different vendors without having to re-instrument all of your software, which is great. This has been a real sticking point for users. But it still means that you need to, make the right choices.
David, do you have any preferences on what the client or the agent should look like, or any advice on how to manage that process?
Yeah, I mean, I'm a big fan of OpenTelemetry as well. I don't think any software team out there is really doing particularly anything special or unique. We're all writing software that responds over gRPC or HTTP. Most applications look very much the same when you're looking at them from the outside. And the way that we monitor and observe them can be mostly generic to a certain point, but the way that we instrument our own code ourselves to add that extra context and metadata is equally important. So I think convention and generics with OpenTelemetry and Prometheus or even InfluxDB are all great and will get you a really great starting point, and then they can start to bring in
observability. I would, if you're using pre-aggregated metrics, you can't get the kind of observability that I'm talking about. You can only get monitoring. If you're using pre-aggregated metrics, you don't get that arbitrarily wide structured data blob per request per service, and that means it's very difficult. It's very easy to see a spike, but it's impossible to actually drill down into that spike and see which requests are different and why.
I completely agree. I definitely am not one for saying we should, only use Prometheus and have pre-aggregated metrics. We really do need to have higher resolution and higher cardinality on our things. And I think that makes a lot of sense. And I think, if you're at your first 1,000 users, do you really need to go down that route? Maybe not. You can start off with...
You need to? No. But is it easier if you do? Yes. Again, this kind of goes back to this is the easy way to do things, is to start out this way. It's not the hard way. It's the easy way to start out. It's like putting on your glasses before you drive down the road. Can you get down your driveway without them? Yes, but it's not easier. It's harder. And I really think this is a kind of a shift that if you're adopting microservices, you need this because otherwise the hardest problem in distributed systems is not what code is broken. It's where is the code that's broken. And without high cardinality, high dimensionality in your instrumentation, you have no prayer of figuring it out.
Do you guys think that microservices are hand in glove with Kubernetes and containers, or are people building microservices and things other than containers, or should they be just all containers?
It's just infrastructure. You can do it with ASGs and VMs. You can do it with anything that you can provision dynamically is fine.
You can definitely, but and I'm going to say after this, I really dislike. There are things you get for Kubernetes for free after you've paid the adoption tax, like service discovery, through through DNS labeling and stuff like that you would have to build yourself using console. And there are tools to do it, Kubernetes isn't the only way, but there's still a lot of things with Kubernetes that you get through convention. The ability to have multiple containers in a pod is relatively unique there, which allows us to use sidecars and enhance our applications without changing our own code. But you can do it with autoscale groups. You can do it with console. You can do it with Route 53 internal DNS. So you can, but Kubernetes, I think, if once you've learned and paid that initial tax, gives you a lot of those things that are work over convention rather than having to go and learn something.
Charity, why don't you think we see more microservices-based apps? I feel like we're talking about it for a while now, but
it's hard.
It's hard. Okay.
It's hard. It's hard, and because, especially if you're talking about enterprises, that traditional DevOps thing does not work. You have to own your own software, and that's a pretty steep hill for a lot of teams to climb.
What's your best advice to help them climb that? What would you, if you walked into a new gig tomorrow and they were just getting started, what would you lay out as kind of like a quick, fundamentals, basics, this is what we need to do and to get ourselves aligned for the right thing down the road?
Well, I don't know. I would have to ask them a lot of questions before I even conclude that this was the right thing to do.
All right. Well, what questions would you ask then? What comes to mind?
What are your scaling problems? Where do you spend most of your time? What are your pain points? What does the topography of the team look like? What are the goals for the next year, 5 years?
Do you think enough IT people ask those kinds of questions, or are they just kind of throwing developers at code and say, code faster and hope that it all works out at the back end?
I mean, you kind of answered your own question. We're all human beings, right?
David, what do you think? Do you think we need a more thoughtful, structured approach? Should there be a class for managers about how to put together microservices teams?
I mean, I'm guilty of this, right? I'm a bit of a technology magpie. I always want to go play with a new language. I always want to go play with a new tool. And microservices is an enabler for that within certain organizations to experiment more. Whereas if they're working in a monolithic architecture, they're probably bound by the same tools that the team is familiar with. So, yeah, but not that I would ever encourage everybody to go and adopt microservices because they have all of this newfound flexibility. But make sure you're solving a problem first that your team actually has. Like Charity says, understand how big the team is, what the topology of the team is, where are the problems, why are they losing their business advantage against their competitors? Are they moving quicker in a certain area, and can they change their model to work with that? Maybe they're just trying to get better understanding with their data lakes or anything like that, and they want to improve their tooling there. Doesn't necessarily mean they have to re-architect their entire application to be microservices. So
I would also ask them how long it takes them to ship software, because I think that for most teams, actually achieving actual continuous deployment, continuous delivery would be more impactful than adopting microservices.
Do you think that there's kind of a chicken and an egg? Would they actually do CI/CD first and then get to microservices second? But it almost feels like to me they go, hey, we're doing microservices and now we need all this infrastructure to go with it. So is the cart before the horse? Is that kind of what you're after?
I don't know, man. Like, I have a hard time thinking that anybody with a multi-day lead time to ship software is going to be successful at microservices.
David, what do you think?
Yeah, I'm not convinced I would ever want to try and build a distributed application with service discovery on top of Kubernetes without having a really strong CI/CD situation. I think you would just be fighting yourselves more than you would be fighting the software, and would have a net negative effect all around.
All right. What do you guys think? Do people underestimate the infrastructure issues around the latency of microservices? And do we need to go back and kind of look at what the underlying hardware is, David, in these environments? Or do they assume that, for some reason, the laws of physics have been suspended and we can just make all these distributed microservices work as is?
Yeah, I mean, I definitely think, moving to a distributed architecture does add latency to every request, depending on how many, different services each single end user request has to go through before it can be satisfied. That's an architectural pattern and decision that the team has to make, depending on how complicated their system is. But, I haven't seen it ever be dangerously bad where, we're taking a response time for an end user from 300 milliseconds to 4 seconds because it had to go through all those systems. That would be a problem with the way that it's designed it. I wouldn't say latency to end user request is don't adopt microservices. I've not really seen that limit come in there yet, but maybe I'm wrong.
All right. Charity, do you think the microservices applications are more resilient? One of the things people say is they're supposed to degrade gracefully when something doesn't work, but it seems a lot of times there's a single point of failure or a dependency that somebody didn't find. So what is the real state of the resiliency of these applications?
They can be. They have the potential to be. They also have the potential to be way worse because you have way more points of failure. It all comes back to, you know, the operational intelligence of your engineering team. You know, it's not a magic bullet. It's just it is a path towards achieving more resilience. You know, when you've got your monolith, you hit an exception, the whole thing crashes. There's not a whole lot you could do about that. When you've broken that up into a bunch of, you know, different services, you have more options, but it also takes a higher level of operational awareness and on everyone's part, because one dumb actor can absolutely bring the whole system down. You know, and you have to look at your storage systems too, right? If you've got a bunch of microservices and they're all backed by the same MySQL primary, well, you're not going to have much resiliency there. So it's a systemic thing. Distributed systems are hard. They're hard. They're often counterintuitive. They're full of traps for the unwary. This is why I said, you know, you must be this tall to ride this ride. And I think that, you know, adopting microservices before you've got some of the basics down is just going to be a recipe for a lot of pain.
What exactly should go into an observability platform? Because we've been hearing about APMs forever and people have had monitoring tools forever. So what is the experience or the thing that I'm going to see that's different from what I used to see in IT before we started banning around the phrase observability?
So I kind of answered this already. You want to instrument so you've got the one arbitrarily wide structured data blob per request per service, and you need high cardinality and you need high dimensionality. You also need to avoid the systems that force you to declare any kind of indexing up front, or, you know, any kind of schema up front, because observability is all about enabling you to ask questions about the unknown unknowns, which means that anything that locks you into, you know, a set of these are the only questions that you can ask up front is kind of anathema to that. So, you know, I would say as of now, the only two observability tools out there are Honeycomb and Lightstep, but I do believe that other vendors are trying very hard to catch up quickly.
David, one of our attendees wants to know if there's a difference between scaling up and scaling down and scale out in terms of how you manage microservices and observability. And I guess we kind of touched on this notion of wide area networks and distributed environments, but is the problem going to become more complex as we scale out and we see edge computing? And, you know, what's your thoughts on things that we should be looking for over the horizon?
Well, scaling is one of those things that the better, you know, not observability, but monitoring data you can get out of each service, the better you're going to be able to tune that scaling up and down. You know, like the first pass that most people do is, well, we're going to monitor the CPU utilization of a node or a service or even a container. And if that gets too high, then we want to be able to get more of them. And we'll scale that horizontally until we get a response time across a P95 that we're happy with, or whatever they go with, right? And it's very crude. What we actually really want to understand is how are our users affected? And then that's when observability can kind of come in and we can understand through high dimensionality and cardinality data how users within certain regions are all being affected. And they can be scaled accordingly. But I think charities would be able to touch on that a lot more than I would.
Charity, you want to kick in there a little bit?
You're totally right. I mean, ultimately, what you want to be measuring are SLOs. You don't want to be measuring just the symptoms. You want to be measuring how are our users impacted, and, you know, assigning yourself a budget for those errors, so that you can be alerting your team not whenever, you know, CPU flares and spikes or memory usage, you know, spikes, but when users are actually being impacted negatively.
Yeah, I think it's one of those things, just to kind of touch on that, like you can throw money at scaling infinitely until you run out of money. What you really want to be able to do is scale smartly, and then using SLOs, or understanding when you're willing to just give up and say, right, we're going to have an outage here, we'll fix it, we'll come back to it. That's going to save you money, and you can reinvest that in better observability and tooling and training and whatever. You can't just say when my CPU or my response time is too high, scale up, because eventually you're going to start having a net negative effect on your own systems. You're going to bring your own systems down, and that's not ideal either, obviously.
One of our attendees is also asking about Prometheus plus Grafana. And I think the question is, are we seeing advances in visualization that go side by side here so we can actually see what's going on with these microservices more easily than we did in the past? I don't know, Charity, if you want to jump in there.
It's very difficult to have advances in visualization without advances in the underlying structure. I keep repeating the term high cardinality and high dimensionality, but a lot of these tools like Prometheus, they're time series databases. They're built in aggregated metrics. And a metric is just a number with some tags appended to it. And in time series databases, you can't break down by high cardinality. And when I say high cardinality, I mean imagine you have a table of 100 billion users. The highest possible cardinality would be any unique ID, right? Social security number. Low cardinality would be like gender or species, right? And these time series databases, they're only built to support low cardinality dimensions, when in fact high cardinality dimensions usually have the most relevant debugging information. They help you find the needles in the haystack, right? Because they identify very, very small groups or individual users. So, visualizations will help to some extent, but at some point you got to ask, is this the right tool for the job? And when it comes to, I believe that monitoring tools are great for understanding infrastructure. But when you need to understand your code, the stuff that you are writing and shipping every day, you need observability. You need instrumentation and observability, and that's just a different tool set. And you're only going to get limited results if you try to apply monitoring tools to an observability problem.
Let me follow up on it. Do you think, though, that at some point I need to correlate what I'm observing in the software back to the hardware, and is there a best way to go do that, or are they just always going to be separate motions?
Honestly, I think that it's fine for them to be separate. I think that the trends that we're seeing in software are towards, hardware being less and less our problem. If you look at like serverless, right? What's going on in the hardware? I don't fucking know, right? I can instrument my code. I want to be able to know at a high level, did memory usage like double after I ship this change? And CPU like spike, but I don't need to care about all of the hundreds and hundreds of things /proc. I just don't care. That is the hardware team's problem. And this is, I think, the general trend in software.
Well, do you also think maybe we're a little obsessed with trying to boil the ocean, and maybe all you really want to do is know if the environment was working 2 hours ago and there was a change, I want to see what happened in that last 2 hours, and I don't need a million metrics. I just need to be able to say, show me what happened in the last 2 hours. And that's
really what you want to be able to know. You want to be able to answer questions about things that you have control over, right? And for most engineering teams, that is the code that they ship. You want to know if anything changed that you can fix, right? For most engineering teams, that does not include, some RAM was swapped out. You don't need to know what's wrong. You just need to know if something's wrong so that you can shut it off. That's the level that you need to understand.
All right, David, you think the infrastructure doesn't matter, or what's going on?
Yeah, I think we're always, depending on your cloud provider of choice, but I work for a bare metal cloud, so I'll kind of spin it both ways now. But you get teams that are going to be working with bare metal for performance reasons, that are providing a platform, and it's going to have very different monitoring needs from the application teams that are deploying on top of that platform, right? Two different sides that worry about two different things. the more you adopt more virtualized clouds like AWS or Google Cloud, then the hardware really isn't important at that point because the platform teams are AWS and GCP. You're an application developer deploying your application to the platform, and that's where you're going to need more observability focused on your code. Understanding why certain database calls take so long versus others. And it's just, it depends what side of that you're on. So.
Yeah, I'm not saying monitoring tools aren't great. I am assuming we're talking to application developers here, and I'm saying that I don't think it's any, you talked about like scope creep. I don't think we can ask any software developer to give a shit about the hardware. It's too far away from what they care about.
Charity also brought up serverless, David, and I'm curious, I would have thought by now we might see a much more broader usage of that, and it seems like it's still coming along. I mean, where are we in that adventure, and what's holding it up if it is being held up?
I mean, I see a lot of adoption of serverless, maybe too much. I mean, my opinions of it are maybe not the majority, but for me, serverless workloads are asynchronous workloads. I'm not a fan of a website, requesting google.com and getting some serverless container that's spun up, spun down, and responds. I think they work well for processing queues and caches and other things. So I prefer a more mixed architecture, but I think people are adopting serverless. I think Lambda is becoming increasingly popular. Tools like OpenFaaS are very popular. I just don't think that the ergonomics of adopting those tools is particularly great yet. Like if you want to run a synchronous HTTP application on serverless, you need an API gateway. The tools for that are not great. You have to manually configure API gateways through either lots of YAML, sometimes as a UI, sometimes as a mix of both. But I just think the developer experience isn't there, and I think that's probably slowing down the adoption. It's not that easy to adopt these tools. There's still a lot of manual labor.
It also doesn't solve all problems, right? It's great for like offline photo processing. It's bad for like, give me sub-second, HTTP, web services stuff. Like, I don't think anybody's claiming that serverless is going to be the future for everything, but the cost economics are there. And for some things, it is fantastic. And in fact, we recently moved our database to serverless. We now run, like, our query planner is effectively some Lambda jobs, and our database, the data files are stored in S3, so it's a distributed database, and it's great.
All right, we have a question about auto scaling, and I'm going to see if I can do it justice here, though. But should I put a load balancer in with a bunch of VMs and some sort of CloudWatch to monitor and scale VMs? Or should I be looking at moving my apps to K8s and microservices and some other way to address auto scaling? And is auto scaling even desirable? Is that what we're after, David? What do you think?
I mean, I think David already answered this.
I'll add a little bit more context. Auto scaling is really important for all applications that have end users. You're going to have to be able to scale to satisfy those users and make sure they're getting a timely response that keeps them happy. Otherwise, you don't have a company. Now, to get specifically to the question there, where they mentioned having a load balancer and then VMs, like scaling VMs has two major problems. One, it can be really slow if you're doing just-in-time configuration management or provisioning. By that, I mean spinning up an Ubuntu box, running SaltStack on it, installing your software, and then dropping it into the load balancer. It's going to take you minutes. It's going to be slow. But then the other approach is to pre-bake your AMIs and then deploy them, and they spin up really fast. But the challenge there is you're pre-baking AMIs and then trying to keep them up to date with security things. Rarely ever happens. I think containers have solved this problem, and they have done for the last 5 years. So while you don't necessarily need to adopt Kubernetes to do auto scaling, you do want to adopt containers and deploy containers as an artifact. I think most, if not all, should be looking at that. But you can also use things like a HashiCorp's Nomad if you don't want to go down the Kubernetes monolithic beast of orchestration. There are other approaches that can be simpler and still as effective.
See that? Now you're confusing everybody. You're using the phrase monolithic and Kubernetes together, and everybody's like, what? Wait a minute. Is there an ideal moment, Charity, to one of our attendees wants to know, to introduce observability? Should that be, I think you said from the very start, but I guess the question is being asked, are there other points in the process where it makes more sense, or are there different levels of observability to add at different times?
It's never not easier to have observability. Like, building software blind is really hard. building it with some view into what's going on internally is just easier. So yeah, I'm a big advocate of, building in from the start so that you build your muscle memory, to be instrumenting your code and to be looking at it after it's shipped and, through the lens of your instrumentation. Is it doing what I expected? Does anything else look weird? Like, I think that muscle memory and that cycle is it's never not easier to have it. So yes, I would advocate doing it from the beginning. If you don't have it at the beginning, there's no time like today to start. It's a different world when you can see into the box.
Yeah, developers should just go find all those print statements they've got in their code, change them to some sort of JSON blob and have them write somewhere and then collect it.
Okay, that sounded like magic, maybe. David, let me ask you this. Since one of our attendees is kind of stitching together a bunch of comments, so I'm going to interpret and hope for the best. But it seems like we are moving away from more batch-oriented applications and more real-time, and we're trying to process data and analyze it where it's collected. Maybe it's out of the edge or somewhere else, wherever it happens to be. Is that changing the nature of the application environment in a way that requires more observability, and does microservices drive that, or do you think that these are kind of orthogonal trends that are happening side by side but they're somewhat supportive of each other but not directly related?
Yeah, I think we've been moving away from batch-oriented systems for a long time. I haven't had a senior manager come up and ask me about ETL in at least the last 6 years. So to me, that's a bonus and a good thing. Mm-hmm. We are moving towards stream processing. We are looking at, tools like Kafka or, NATS, other message brokers that allow us to scale independently the consumption of those messages at a pace that we can handle, rather than batching them up and offloading them to some other system like Hadoop. So I am happy, and I like seeing more of that trend and that push towards real-time streaming-based systems and saying goodbye to batch. I'm definitely not much of a fan.
All right. Charity, let me ask you, you've been at this for a little while now. What's the worst thing you've ever seen anybody do in terms of moving towards microservices? And don't name names.
Oh my gosh, that's quite the question. What is the worst thing I've ever seen anyone do? I'm just staggered. Most of them probably have to do with using data. Although there was the team, the 12-person team that I saw that had over 50 microservices. That was a real standout. I don't know, man. This is a very challenging question. There's so many ways to screw up computing. I think that the worst categories of mistakes all come down to number of services, splitting up services in just truly terrifying ways, or just going so far down the rabbit hole of, I'm going to make a service for everything, that they actually forget about the point of what they're doing, right? Like, we can't ever afford to forget that we're solving business problems. We're not creating sandcastles and puzzles in the sky.
Do you think that there is maybe an optimal number of microservices that I should stop at, or is it? I know it can depend on case to case, but or is there at some point a number that is just ridiculous?
I'm hesitant to. I don't think that. This is why we get paid lots of money, right? Because there aren't any easy answers. It really is all about understanding your use case and your team and, finding the right answer.
Can I add to that?
Sure.
I think it's important to remember microservices solve a human problem before they solve a technology problem. Like, microservices are there because you cannot have a team of 200, 500, or 600 or 5,000 developers working. Well, very difficult to have them working on a single code base, working on the same files.
Until a couple years ago.
Shouting across the room, "Are you in that file? I'm going to push it. Oh, there's a merge conflict." At a certain point, you start spending more time on toil than you do shipping features. And microservices allow you to break that down, as long as you get them coupled in the right way, or as loosely coupled as possible, and understand your bounded context. Looking at methodologies like domain-driven design and understanding how to architect those systems is really important. but do it to solve a human problem. Don't just jump into microservices because they're cool and shiny. I mean, that's something I would do, and I'm wrong. But make sure that you've got a team that's going to have proper benefits from adopting it and know how to structure it and make sure they're doing continuous delivery and all those things. So microservices, human problems first, then technology.
All right. See, David, don't be like David. I don't want to let you off the hook on this other question, though. So what is the worst thing you've seen somebody do?
Time and time again. I mean, I was a consultant previously, and I helped people adopt containers. I helped people adopt Kubernetes, and I always used to say the first step was just to get your application in a container and build out that CD pipeline. But the problem is they then started to adopt microservices, but they would have them all pointing to the same database, and that is just the biggest no-no, right? That is going to cause you so much problems. Now, they think they're okay because they've got it separated, and but they each use a different table, or they each use a different database, right? This is not fixing any problem. This is number one cause of pain and suffering in any development team will be microservices pointing to a single Postgres or MySQL or MongoDB or whatever, and thinking that tables or databases that are appropriate boundary, because they're not.
Well, let me ask you the other extreme of that question then. Should every microservice have its own little database then? And does that become problematic?
So, I mean, as close to that as you can get. I'm not going to be completely dogmatic with it and say yes, although I'm very close to it. I'm a big fan of CQRS and, having microservices structured in a way where you can have your write workloads go to an event system, event sourcing if possible, and then your projections and your read side being delivered by something else. Don't necessarily need a database per each, but you do need to break up the workloads to fit the way that the user engages or requests or consumes that data is more important.
Do I then wind up with an issue where I'm trying to synchronize all the databases to keep them consistent, or how do I deal with all of those databases?
I would hope you're not synchronizing all of those databases. I'm sure at some point an exec is going to ask you for a single pane of glass, and I would suggest you walk away as quickly as possible. But there are tools there. You can write this. You can write aggregates. You can write projections to something like Kafka and consume them in another service, which uses a tool built for the job, like Bigtable or something else, and leverage that. But your end user should never be hitting that system.
All right. Charity, you're kind of looking at all this data that's coming in, and everybody and his brother seems to be throwing around the phrase machine learning algorithms and AI these days, and that can mean almost anything you want, I guess. But do you think that machine learning algorithms and observability have some kind of role where they converge? Is there something cool coming over the horizon?
Well, where are you throwing in observability with machine learning and AI? I mean, machine learning is definitely a powerful tool that you can use in many cases. AI maybe as well, although mostly I see it used to raise money, and it is bullshit. I don't know, dude. It's all about your use case. It's all about what you're trying to do. I don't see any magic bullets coming our way, if that's what you mean.
David, any magic on the horizon? Any machine learning algorithms can help with something?
I mean, I think machine learning, not something I'm at all knowledgeable about, but, if we think of observability as a way to answer questions, to solve problems, or, I think Charity always says the unknown unknowns and questions that we don't know how to ask yet. Like, machine learning is really good at finding patterns, and it might be able to help you find new questions that you've not asked before, but I don't think it's going to give you answers.
All right. I was hoping that someday I would come to work and I would just be able to ask a machine to, tell me the 3 things that I'm going to get fired for today, and let's prevent them.
Humans are really good at finding patterns, but only humans can ascribe meaning to those patterns. I can see a spike on a graph, but only a person can tell me if that spike is good or bad, right? So
we're all going to be employed forever. Is that what you're saying?
I mean, I plan on it.
I hope
so. Do you think that, and without getting too hard into your own companies and whatnot, but it seems like when I turn around now, everybody who ever sold a monitoring tool is now selling an observability platform, and there's all kinds of startups in this space. So I think I lost count. There must be 27 companies that want to be in a quadrant somewhere. So, is there going to be some sort of convergence consolidation in this space? David, we'll start with you because I'm pretty sure I know what Charity's going to say.
I mean, I think there's definitely companies out there that are guilty of taking their very simple monitoring tools and calling it observability. I think we've all seen it. But, observability, I don't feel it's something that you're going to get from a tool. It comes from the team instrumenting their code and then having the tools to help them understand that. So it's not like you can just have Grafana and Prometheus and say, oh, I have observability, or Datadog and say, oh, I have observability. It's not really going to happen. There's more to it than that. And companies like Lightstep and Honeycomb are probably leading in that way.
What do you think, Charity? Is there such a thing as an observability platform, or is it just something you do as a human and then there's a thing that helps you do it?
I don't know what observability platform means, but of course there's going to be consolidation because vendors have been out there charging you to store your data once for monitoring, once for logging, once for tracing, once for, and it's just, that's ridiculous. Like you should pay to store your data once. And if you store it in the right way, you should be able to ask all of those different questions, right? So of course there's consolidation in the space. There should be, because people shouldn't be, not only is it costly to be paying for God knows how many tools to understand your data, but it's actually less effective and impactful if you have to store it that many times, because you have to like copy paste an ID from your logging system over to your other system because, or you have to like correlate visually, go like, well, that timeline kind of lines up with this timeline on the tool. Like, it's just nonsense, right? Like your tool should be able to do that for you.
I'd love to get your opinion on this. I once asked this fellow, I said, we have these great tools for you. You can put all this stuff together. And he goes, well, that sounds great. The only problem is I have no idea what questions to ask. So how does one learn to know what questions to ask from an observability or monitoring platform or whatever it is? What should I be thinking about in that regard?
This is why engineers need to own their code, because as you're writing code, if you're familiar with the concept of writing tests, then you should be familiar with the concept of observability, because it's all about predicting ways that it might fail, adding instrumentation to find those ways, and then looking for it.
David, is there any shortcuts to learning how to ask the right question?
Your customers are probably asking those questions, so listen to them. When they're paying or if they've got complaints, then you need to understand what's going on.
All right. Let's just say you were in charge of, you could be queen or king for the day. What would you kind of want to fix among the technology today, or what is the thing that, as it relates to observability at least, that is broken in your mind and we as an industry need to focus more on? Charity.
We've got decades of, I would call it technical debt, just around metrics, right? And I understand why metrics are what we went to first as an industry, because they're cheap, and they give you some answer, and something is better than nothing. But hardware is now very cheap, and the explanatory ability of a metric is very low. And I really believe that we need to move it to the wide events in order to, because when you have wide events, what this does is it unlocks the ability for you to go, all of the requests that have this thing wrong with it also have these other 5 things wrong with it, and to do that sort of rich correlation. And most of the problems that you have in modern systems are not just going to be simple ones. They're going to be complex ones. They're going to be ones where it's like, oh, the errors are coming from requests that are from iOS on, this iOS version, this build ID, this language pack, this, this region of the world, this, a whole trail of things there. And your ability to track those down with metrics is it's almost impossible. You basically have to run on gut intuition and past scar tissue of previous outages, but your systems don't fail in the same predictable ways as they used to anymore.
All right, David, you're king for the day. What's the thing you want to fix or change?
Even with a few extra minutes there to think, I'm still struggling. That's a really tough question. I think, solve today's problems before you solve tomorrow's. I think we're very quick in our industry to reach for new tools, new shiny things, or, worry about scaling issues that we don't really have yet. I think if we focus on, just the thing that we need to ship now and increment and get comfortable doing that faster, then you don't need to do big, massive rewrites or adopt new architectures so quickly. We can
So continuous deployment is what you're saying.
Yes. Yeah, I know. Do the easy, well, not the easy thing, but do the right things first and get them right, and then you can start to take on tomorrow's problems and make things better. But
all right. Speaking of shiny things, one thing I didn't ask both of you is, we hear a lot about distributed traces these days. Is that the new shiny thing, or is this going to solve all our issues, or is it going to be this combination of logs and metrics and everything else, and you got to shake and bake it to make it work? Charity.
It's not going to solve all of our issues, and it's not very new. It's been around forever, but it is a very useful, and I would say probably necessary tool if you are adopting microservices, because so often, the hardest problem, like I said before, is not going to be fixing the code. It's where in the system is the code that I need to fix. Unless you can slice and dice, request your services to see where the time is going, you're going to have a really hard time fixing it.
All right, cool. What is your guys' thoughts about, are we going to see these job functions finally converge? And we're kind of coming up in our last 5 minutes, but one of the things that I'd like to get at here is, it seems like there's all these jobs and tasks within the land of IT, and if developers are going to end their stuff end to end, are we going to see all these roles and functions just converge?
I mean, I would argue that they never should have diverged in the first place. In the beginning, you didn't have DevOps. You just had people writing code and owning their code. And when the users would complain, they would fix their code. And then we saw this explosion of like complexity and stuff. And so we, specialized. But I absolutely think that, I don't think that the total amount of stuff that we're responsible for is expanding. I think that it is, the shape of it is changing, right? Like I remember getting paged, having to drive to the colo to flip the the off switch, on switch on the MySQL primary. I don't have to do that anymore. That's great, right? So I'm responsible for less this way, but more this way. And I do think that being a generalist who can sit on top of a couple of domains is kind of a superpower.
All right, cool. David, any last thoughts on that subject?
Yeah, I think it's probably always going to be much of the same. People are always going to find specialities, and I think having more people that are generalists is really important. I think if we remember that we have, platform providers and platform consumers, they have very different concerns. Like, I can't tune an NVMe disk. I'm not going to be good at, scraping SNMP metrics and understanding what's going on with routers and bridges, but I'm good at applications and deploying them. And I think there will be some divergence, but I think we all need to be good across the stack.
All right, great. Hey guys, I want to thank everybody for spending some time with us, and Charity and David for sharing their expertise.
Thank you.
Thanks for having us.
All right, and our winners today were Don M., Juliana K., Philip T., and Julie H. Thank you all for attending, and everybody observe and learn, right? You got nothing to lose. Thanks, guys. Bye.